So this week I rewatched Mean Girls and I love that film. I want to talk about the maths problem from the maths competition at the end of it. So, kind of climax of the film, the mathletes go and they're in a competition, and it gets to the point where Katie has to has to answer one question to win the competition, and her opponent incorrectly does the problem, and then Katie does it. I want to talk about how you would actually solve that problem. So, I got it here. The problem was to find the limit of this thing. So the limit as x tends to 0 of this quotient here. Now the problem here is if you put x as 0 into both the top and the bottom, they both end up as 0, so you end up as 0 over 0. So, just to show you where that comes from, if we put the 0 into this, we get log of 1. Log of 1 is 0. Sine of 0 is also 0. So on the top we've got 0 minus 0, which is 0. On the bottom, well, the 1 is 1. Cos of x, cos of 0 is 1. Squaring gives you 1. 1 take 1 is 0. So we've got this problem. 0 divided by 0 is ill-defined. Does it shoot off to infinity? Does it go down to 0? Or is there somewhere in between that it gets to a proper number, like 1? And all three of those cases are things that can happen with different functions. We have a standard way in when we're solving these sort of things, and it's in the formula books in MEO. It's called L'Hopital's rule, and it is something that I first did when I went to university, but it's a useful little rule, so I thought it would be worth talking about here. If you're one of my first years, you won't have met some of the things that we're going to be doing in this video, but still watch it. So, for instance, you haven't met this beast over here, which is called the natural log, don't worry about it. And some of the differentiation is stuff that comes up in C3. Sorry, I'm talking about the syllabus quite a lot. Okay, let's play through. The idea of L'Hopital's rule is if we have something where we have 0 over 0 or infinity over infinity, if we can differentiate both the top and the bottom, then the differential of the top divided by the differential of the bottom, if its limit exists, then it's the same limit as the original thing. So what we're going to try and do is differentiate them, and I hope to get something simpler that we can actually evaluate. Let's give it a go. So, the limit as x tends to 0 of, if we differentiate the top, well, log of u goes to 1 over u, but we've got an extra factor of minus from in here, so we're going to get minus 1 over 1 minus x. You can do it by substitution, you're going to be careful. This thing over here, well, we've got minus, sine goes to cos, all over this thing over here. Well, 1 is constant, it's going to differentiate to 0. You can do the cos squared with either chain rule or product rule, but you'll get the same thing. That you'll get 2 sine x cos x. The negative's been absorbed because cos differentiates to negative sine, so we've got another negative coming out which cancels out with the first negative, so it's positive. If I don't really like having these kind of nested fractions, so I'm going to times the top and the bottom by 1 minus x. So I've got the limit as x tends to 0 of, that's going to be minus 1. This thing over here is going to be negative cos x plus x cos x. Just make that nicer. X cos x. Underneath, we're also times it by 1 minus x, so I'm just going to write it in factorised form. Cool. Right, so we've got something that we can deal with now. So, there we go. If I try putting 0 into the top, I've got minus 1, cos of 0 goes to another negative 1, so I've got minus 2 so far, and the x in that cancels it out to 0. So on the top we've got negative 2. On the bottom, if we put 0 in, well, we've got 2 times 1, which is 2, times this thing is going to go to 0. So we've got minus 2 over 0. Now, dividing by 0, again, we don't like. But this is the limit as x tends to 0. So if we go, we're going to try it in 2 different ways. We're going to try putting in a number which is slightly above 0, something very small, which we can tend down towards it. And then we're going to try the same sort of thing going from below, so negative 0.01, so that we can home in on 0 from the 2 different directions. If you try this, we're very much into the realm of get your calculator out now, but you'll find that if you try something positive, but very small, you'll get something tending towards negative infinity. If you try something negative in here, but again very small, then you'll get something tending towards positive infinity. And the graph of this looks a bit like this. With asymptotes going up, so we've got this tending to positive infinity, this tending to negative infinity. But because those 2 things contradict, this limit here doesn't exist. It's not defined. The limit does not exist. Now, in the film, she does this without really thinking. There are other ways into this. You could use Taylor expansion, but there's no way you can do it when, well, in 5 seconds, as they try to in the film.